Okay, so I am recording this in case we don't get to see each other on Tuesday due to hurricaneness. So just in case I'm recording. So this is our normal in-class where we do our in-class problem sets. So we're on chapter 4 and we're doing organic compounds. And so when you're doing organic compounds, one of the things I want to remind you of, right, if I can put it up here, is that carbon always makes 4 bonds, right, to other atoms. Whether that is carbon to carbon, carbon to oxygen, carbon to hydrogen, carbon is always going to have 4 bonds, right? Oxygen on the other hand, will be uncharged if it has 2 bonds and 2 lone pairs. So 2 bonds and then 2 lone pairs, right? So just kind of remember that, and that's a good way to keep track of all the different things that we're going to have to draw, because we're going to have to draw a bunch of stuff. All right, so we're doing the evens. So describe the difference between a Lewis structure and a skeletal structure in terms of atoms and bonds shown in the structure. So Lewis, when we talk about a Lewis structure, we are showing all atoms, we're showing all bonds, and we're showing all lone pairs of electrons, right? That's our Lewis. Okay, now skeletal. Remember skeletal, bare bones, bones and skeleton, bare bones, right? So what does it show? It shows bonds between carbon atoms as lines, right? It shows bonds, the carbon hydrogen bonds are not explicitly shown, not shown, right? So it's just the carbon-carbon. Anytime you have carbon and other atoms shown as lines as well, right? So anytime you have a line, it's showing you where 2 lines connect. So if I did this, I would know here and here I have a carbon. And if I did this, I would have 1, 2, 3, 4 carbons, right? So anywhere you have a carbon atom, anywhere where 2 lines meet, or at the end of a line, if no other atom is shown, right? If I had this Cl, that would tell me that I had a carbon, I have a carbon, I have a carbon, but the last one would be a chlorine. So be careful that you can look at lines and know where carbon atoms are. That's really, really important. Okay, 4.4. Explain what a condensed structure shows that a molecular formula does not. So now we're talking about the other 2 kinds of ways to draw things. So condensed is going to show me the arrangement of atoms. For example, and a molecular formula just tells me atoms and the number of atoms. Ooh. Well, let's not say atoms, let's say elements and number of atoms of each element, right? So let's do an example. So I could have a molecular formula that is C3H8. And so if I wanted to write C3H8 as a condensed structure, I want to show the arrangement, right? So I have 3 carbons. Those 3 carbons are going to be linked to each other, but we're not going to show those bonds. We're just going to say, okay, I have 3 carbons. I know to complete my octet, if I have a carbon on the end, this carbon needs 3 hydrogens, this carbon needs 3 hydrogens. the carbon in the middle already has a single bond to each of the hydrogens, so this one only needs 2. So we have the overall arrangement of atoms in that condensed structure. Whereas in the molecular formula, all we're told is we have carbon, we have hydrogen, and how many atoms of each element we had. All right, let's see. Draw a skeletal structure for each of the following compounds. Okay, so we're gonna switch from molecular to skeletal. So I'm gonna first draw it with my dots like I was doing just a second ago, and then we're gonna draw what you should be drawing on like a test or something like that. Okay, so I like to number my carbons so that I can kind of keep track of what's going on. So I'm gonna number this 1, 2, 3, 4. And remember, you always kind of want to number where you get the longest chain of carbons. And so this just helps me remember to put everything in the right place. So I'm going to start with my first carbon, and I'm going to go to my second carbon, third carbon, fourth carbon. Okay. Now I'm going to attach my other stuff. I can see here on carbon 2, I have a CH3 attached. So I'm going to draw a line, and that's another carbon. But I'm not going to worry about drawing my hydrogens. And then on the fourth carbon, I have a hydroxyl group. So I'm going to put an O, that's an oxygen, and a hydrogen. Okay, so that's kind of my structure. I want to make sure 1, 2, 3, 4, I have the same thing. So on the second one, I have another CH3, and on the fourth, I have an OH attached, and that's indeed what I have. So now, don't do that on a test. That's not what a real skeletal structure looks like. A real skeletal structure is just the lines. So be careful that you do that. OH, and then one up here, and that's it. So that is your real skeletal structure for the compound. Okay, all right, now this is a Lewis structure. So I'm gonna count my carbons, 1, 2, 3, 4, and then kind of identify what's different. So on carbon 1, I have a bromine attached. So I wanna make sure that I replicate that, right? So here I'm gonna start with a carbon. I'm gonna go up to carbon 2, down to carbon 3, up to carbon 4, okay? Now I need to go back to my carbon 1, and I need to add a bromine to it, okay? And so I'm gonna go back and number them 1, 2, 3, 4, and attached to 1, I have my bromine, and that was the only other attachment that I had. So I am good. So now I want to rewrite and make sure that I have it right. 1, 2, 3, 4. And then coming off of the first one, I have a bromine. Okay. So just make sure you count your carbons. That's my biggest advice. Count your carbons, right? Okay, let's see. Now we got to go back. We're going to draw a Lewis structure for each of the following compounds. So we got to go backwards. Now we're going from skeletal to Lewis. So what I like to do, again, is I'm going to number my carbons. 1, 2, 3, 4, 5. So I know I have to be careful. I have a chlorine on carbon 2, and I have a chlorine on carbon 3. So I need to make sure that when I draw my Lewis structure, I'm getting that. Okay, so I'm going to do that. So I need 5 carbons in a row. So carbon 1, I'm just going to do it that way. Carbon 2, carbon 3, carbon 4, carbon 5. Just to kind of keep track of it. I can go back and erase my numbers after, not a big deal. So what I want to do before I put in my hydrogens is to put in my other stuff. So I know on carbon 2, I need a chlorine. And I know on carbon 3, I need a chlorine. So once I've made sure that all my other stuff is attached, and those are the only 2 things, and that matches up, now I'm going to go in and add my hydrogens. So now I can put in enough hydrogens to complete my octet. So how do I know I only need 3 hydrogens on the end? Well, these 2 carbons have a single bond between them. Same thing with carbon 2 to 3, same thing with 3 to 4, and same thing with 4 to 5. So when you're putting your hydrogens in, make sure that you don't give them too many hydrogens and you give them all the bonds they need to the other carbons. So I'm going to go in and finish drawing our hydrogens. And there's our structure. So don't leave your numbers in, kind of take those out. Oops, don't remove your carbons. All right, so there you have it. You have your Lewis structure. Okay, now we're going from a condensed form to a Lewis structure. So let's again count our carbons to make sure we have the right number. 1, 2, 3, 4, 5. Now what do I have attached? Well, on carbon 3, I have a CH3, and on carbon 5, I have a bromine. Okay, so I'm going to want to make sure to include those things. So let's do carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. Okay, now I'm going to put in my other junk first. So on my carbon 3, I have a carbon that has 3 hydrogens. Okay, and then on carbon 5, I have a bromine. And because you're given the basic structural outline, you're given all the hydrogens in this. So this is kind of easy. Our carbon 5 has, in addition to 1 bromine, it has 2 hydrogens, right? So we're kind of told already what we need. So I'm going to go ahead and erase my numbers and put in my single bonds between my carbons. And then I'm going to make sure that my carbons and hydrogens are the same. So carbon 1 had 3 hydrogens. Well, that's easy. Carbon 2 had 2 hydrogens. Carbon 3 only has 1 hydrogen because it's already got 3 bonds. Then carbon 4 has 2 hydrogens. And our structure is complete, okay? All right, let's see, we're going down. Gotta zoom out a little bit. Okay, 4.10. So draw a condensed structure for each of the following compounds. All right, so let's number our carbons. 1, 2, 3, 4. All right, so a condensed, we're not going to show bonds unless they're branching off of the main chain of carbons. So my first carbon, carbon 1, has 3 hydrogens attached to it. So I got carbon 1. Carbon 2 has 1 hydrogen attached to it. And coming down, we have CH3. Got this one and I got this one. Now I'm going to go to carbon 3. And remember, you're not going to draw a bond. You're going to do C that has 1 hydrogen. And then attached to that, we have NH2. So I got that carbon and my NH2. My last carbon 4 has 3 hydrogens. And that's it. All right. Now, we got to go from skeletal to condensed. So again, you want to number your carbons. So let's number our carbons. 1, 2, 3, 4, 5. Now I see 2 things going on here. I have a double bond between carbon 3 and carbon 4, and I have a bromine attached to carbon 5. So I need to make sure to include that. So my carbon 1, I have 1, 2, 3, 4, 5 carbons. I have a double bond between carbon 3 and 4. So that's 1, 2, 3, 4, 5. So between 3 and 4, I have a double bond. And then on my last carbon, I have a bromine attached. But remember, we're doing the condensed structure, so we're not showing any bonds unless they're double bonds. We don't show single bonds. So let's start from the beginning. Our first carbon, because it has nothing else attached to it except a bond right here, and we're not going to draw that, it's going to want 3 hydrogens to complete its octet. Then our second carbon, we're going to want, it has 2 bonds, 1 here, 1 there, but we're not going to draw them. So it needs 2 hydrogens. Our carbon 3. Now our carbon 3 has a single bond to the carbon behind it and a double bond to the next carbon. So that's 3 bonds total. So it can only take 1 more. I need to kind of scooch this over. And so it's only going to want 1 hydrogen. Carbon 4 has basically the same thing. It has 2 bonds to the carbon behind it and 1 bond to the carbon in front of it. And so it only needs 1 more bond, so it's only going to get 1 hydrogen. Then our carbon 5 has a bond to the carbon behind it and a bond to the bromine, and so it needs 2. So we're going to do CH2. So there's our condensed structure. So anytime you have something weird, like a double bond, you're gonna draw that in. Okay, now we're going on to section 4.2, alkanes, right? So remember, in alkanes, it's only single bonds to carbon and hydrogen, right? We also call these saturated with hydrogens. They're hydrocarbons because they're only hydrogen and carbon. And remember your little mnemonic to remember the first 4. Right here, the first 4 are me, eat, peanut butter, so methane, ethane, propane, butane. And then starting at 5 and below, we're using those prefixes that we used before. And remember, you have that formula of however many carbon atoms you have, your number of hydrogen atoms, you take that number, multiply it by 2, and then add 2 more. And that will give you your number of hydrogens. So kind of remember that. Okay, the first one we have to do is 4.12. Name the straight chain alkanes or cycloalkanes whose structure or formula is shown. C2H6. How can I know if that is a cycloalkane or an alkane? Well, I have to look at my formula. Is my formula CnH2n or whoop, if I could erase this, or CnH2n plus 2. So this is my cyclo, this is my regular alkane, okay? Okay, so our C2H6 is telling us carbon is 2, right? And my hydrogen, if I do 2 times 2, that's 4, plus 2 is equal to 6. So I have a regular old alkane. So C2H6 is, remember, me, eat, peanut butter. E is for eth. So it's ethane, right? Okay, now look at B. B, you're looking at the structure, so I can tell you right away it's going to be cyclo, CYC, cyclo. Okay, so now I just need to count how many carbons do I have. You can start anywhere. 1, 2, 3, 4, 5. My 5, remember, it's me, eat, peanut butter, and then you pick up on 5, right, which is pentane. So it's cyclopentane, right? Okay, C4H10. So if your carbon is 4, to find your hydrogen, right, to find out if this is a cyclo or if this is a regular alkane, you're going to do 4 times 2, which is 8, plus 2 is 10. So we're again an alkane, and this is 4. So it's me, eat, peanut butter. So B is 4, so this is butane, okay? All right, now what do we got? Ooh, I already did one, right? That I shouldn't have done, but that's okay. So we did 4.14. Did I do this one? No, okay, 4.14. All right, write the condensed structure for the straight chain alkanes shown. All right, butane, octane, hexane. I know they're all going to be straight chain because they don't start with cyclo as well. Okay, so butane, remember, Me eat peanut butter. B is 4. So we're going to have 4 carbons. Octane, oct, like octagon. Octopus, 8 legs. Hexane, hex is 6. All right, so let's draw these. So A, my butane, I know I need 4 carbons. So 1, 2, 3, 4. I like to write my carbons first and then fill in hydrogens to make sure that I put the correct number of carbons. So now on the ends, in order to make 4 bonds, I'm going to need 3 hydrogens. Now on the inside, if there's nothing else attached, each carbon gets 2 hydrogens and you complete their octets. All right, B, octane. Oh goodness, I got to go 8. 1, 2, 3, 4, 5, 6, 7, 8. So remember, on the ends, if it's a straight chain alkane, you give the ends CH3, you give them 3 hydrogens, and then everything in the middle, you give them 2. And then each carbon now has 4 bonds. So hexane is the same thing. Hexane is 6. 1, 2, 3, 4, 5, 6. Give the ends 3 hydrogens and everything in the middle gets 2. Those straight chains are easy. Love those straight chains. Okay, 4.16. Write the skeletal structure for the alkane or cycloalkane shown. I like to look at them and name them and then draw them because it really helps me. It really helps me. So if I look at A, C4H8, if I have that formula where I have 4 carbons and then my hydrogen, if I do 2 times my number of carbons, I get 8. So this must be a cyclo. So this would be cyclobutane. So if I'm going to draw cyclobutane, I need to make a ringed structure that has 4 carbons. Well, it doesn't actually look like a ring. You just make a box. 1, 2, 3, 4 carbons. And don't leave your numbers. So this is A. That's it. It's a box. All right, B. So if I'm going to name this, right, because I love to name them. Let me change my color. So let's see how many carbons I have. 1, 2, 3, 4, 5, 6. So I have 6 carbons. So that is, and it's a straight chain. So it is hexane. So I'm going to draw 6 carbons. Now this is a skeletal structure. So bare bones, right? So wherever I start, that's 1 carbon. That's 2, 3, 4, 5, 6. And double check that you're right. 1, 2, 3, 4, 5, 6. And I'm good. Okay, so I'm going to get rid of my numbers. All right, C. C10H22. I know that doubling it, I'm going to have to add 2, right? So carbon is 10, hydrogen, 2 times 10 is 20, plus 2. So I know that this is a straight chain alkane. So this would have to be in 10. 10 is decane, like a decade, decane, okay? So now if I want to do it, I'm going to start at 1, but I'm not going to do my little dots, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I like to double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. That is exactly what I want. So now I'm going to get rid of my numbers. Okay. So I have decane. All right. Last section, 4.3, are families of organic compounds. So this is my reminder to you, make your flashcards from table 4.4. You want the name and you want an example picture. you know, like you can flip the card that way. Then you can flip the card name versus a verbal description of the functional group. And then you want a set of flashcards where it's the name versus an example. Oh, I already said that, example molecule. So you do want an example molecule. So one you want example molecule, one you want a description, and then one you want just a picture of the side chain of the functional group, right? Not the whole molecule that has a functional group, but just the functional group. So be careful about that. Okay. All right. So what do we need to do? Oh, this is the one where I accidentally did A, but that's okay. Okay. So identify the family of hydrocarbon present in the following. So we're going to look. Okay. B, naphthalene. Well, what I'm seeing here is a ring, and let's count how many carbons. 1, 2, 3, 4, 5, 6. I have 6 carbons, and inside of that 6 carbon ring, I have alternating single and double bonds. So my double bonds there in green, my single bond in red. But then if you look at the next one, right? Oh, double bond, double, 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 and then single, single, single. So you alternate double bonds and single bonds. So this is, if you remember, an aromatic, right? A-R-O-M-A, aromatic, right? So you actually have 2 in this one. It's actually 2 aromatics, right? Makes up mothballs. If you ever smell mothballs, they smell. All right, let's see. Isooctane, a component in gasoline. So when I look at this, I see my main chain here, and then I'm looking, I have things coming off of this main chain. What do we call CH3 groups? Right? We call them, we have a main chain here of an alkane, alkene, right? We have all carbon-carbon single bonds, but we have these methyl groups coming off. THYL, methyl groups. Okay. Let's see. Now we're going to go on. Here we go. 4.20. All right. Identify all the functional groups present in the following. Oh, this is going to be fun. All right. So what you should be looking for are things that look different, right? All right. So what I can say here, in here I have an oxygen double bound and to a carbon, and to that same carbon, I have an OH group. So we call this a carboxylic acid group. So because it has not only that carbonyl, so here's the carbonyl, here's the carbonyl, and here's the hydroxyl, right? So those two things together make up a carboxylic acid group. All right, then the next thing I kind of notice on here is I have some nitrogens, right? I have some nitrogens, but they're different. One nitrogen has only one R group attached to it, and the other has 2. So we're going to name them slightly differently, right? If you remember that. So if you have only one R group attached to it, we call this a primary amine, right? And then if you have 2 R groups, so that's 1, 2 R groups, that is going to be a secondary amine. All right, what's the next thing I see? Oh, I see an aromatic. I see a big old circle. So this big old circle right here, it's 6 carbons and it has some double bonds in it, some alternating single and double bonds. So this is an aromatic. Let's see, what else do I see? I actually see an ester. So right here, I see an ester, right? Because I have that oxygen and then I have 2 things kind of attached to that oxygen and the oxygen double bond. So I'm going to call this an ester. So this is what you have to be able to do. You have to be able to look at a molecule and figure out what are the important functional groups that are on it. Okay, the first thing that I see right here, right, is my aromatic. And you have to be able to know which part of it. You just can't say there's an aromatic and I see 2 rings and I'm going to call that 2 aromatics. It's not. You have to be careful that you know an aromatic is the 6 carbon with the alternating single and double bonds. Aromatic, okay. Then, oh, I see, I identified this in the previous molecule, right? I said, oh, that's an ester right there. Right there is an ester. So I'm going to label that an ester. And then I have another amine group. It's a nitrogen. And in this case, it's bound to 2, 1, 2, right? So we're going to call this a secondary amine, right? Okay. What else we got? 4.22. All right, the most common fatty acids found in animals is stearic acid, a saturated fatty acid containing 18 carbons. Draw stearic acid in a skeletal structure. So what you have to remember is that it is a fatty acid. If you have a fatty acid, that means that you have an alkane. An alkane, remember, is that saturated hydrocarbon, all hydrogens, no double bonds. And at the very end, you have a carboxylic acid. Okay, so I need to end with a double bond oxygen and then a single bond to an oxygen and a hydrogen. But I first got to draw my 18 carbons. Oh my goodness. Okay, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 carbons. Now, attached to that last 18th carbon, I have a double bond to an oxygen. Then I have a single bond to an oxygen and a hydrogen. And that gives me this part being my alkane. And then that gives me this part being my carboxylic acid. Okay. And that is it for 4.1 through 4.3.